Terraform resources. So, basically, there's one thing that gets provisioned here is the SQL Server virtual machine. So let's go take a look at that. So that's here in mssqlwin.tf. So that's pretty straightforward. Windows virtual machine configuration in Terraform here. You can see that we are, name, resource group, location, the size of the VM. We configure the admin username and the admin password. We attach a NIC. We enable automatic updates. And in this case, this is kind of significant. I'm using automatic by OS. And the reason why I'm not using automatic by platform is I'm going to do patching on this server I want to make it possible to do patching on this server using the IaaS extension for SQL Server. And the reason why that's useful is it can patch both the Windows OS and the SQL Server instance running on that machine. So if you're using platform orchestrated patching, it would conflict with the patching that's done by the SQL IaaS extension. So that's the reason why I set it up this way. Got our operating system disk, our image reference. Now the image, of course, is an image that comes from the marketplace that's built by the SQL Server team. So if we go look at our variables here, you will see that the image offer is SQL 2022 running on Windows Server 2022. And the publisher is the Microsoft SQL Server team. So the SQL Server team builds and tests these images for you, so you don't have to go through all the image creation process. And the SQL Server binaries are pre-installed on those images, so you don't have to install them yourself. So that's very useful. The problem is if you just deploy the VM, what you wind up with is a machine with a single OS disk with SQL Server running on it, and that's not very useful. You need to configure it with data and log disks, etc. So that's why we have all this automation in here to do that stuff for you. Okay, you can see here that I'm running the developer edition SKU, so that gives you all the enterprise features. You just can't use it for production usage. Okay. So that's the image information. And here's our provisioner, which registers the VM with Azure Automation desired state configuration. So this runs this AADSC register node PowerShell script. And that, you've seen that before in VNet app. This is just another version of that same script. It just basically does one thing. It registers the node with Azure Automation desired state configuration, and it applies that that MSSQL VM config1.ps1 configuration, this guy here. Okay. NIC's pretty straightforward. The data disks. So what I do here is a little fancy. So I basically have a variable called data disk config. So if we go look at tfvars, or our variables here, sorry. What's the name of that variable again? It was VM MSSQL win data disk config. Okay, here it is right here. So this is a map variable, not just a single value. So basically, I'm creating a couple of objects here, a SQL data object, a SQL log object, one object per data disk. And then I have 4 properties for each of those. The volume name, the disk size, the LUN, and the caching properties. And you can see here, for the data disk, that only supports read-only caching, and for the log disk, that disables caching as per SQL Server recommendations. And this syntax for the volume naming is significant because I use it to pick off the drive letter in my automation. So I look at the volume name and I assume this last character is the drive letter that I'm going to map it to. So if you use this code, make sure you use this format for the volume names. Okay, so that is how we provision the data disk. So we basically loop through each of the objects in that map variable and create a disk for each one. Okay, and then we loop through that same variable to attach those disks to the VM. Okay, and then the last thing we do is we run this virtual machine extension. Okay, and this uploads 2 scripts, a post-deployment script and a SQL startup script. So let's go look at those. Now the post-deployment script is what actually gets run. And keep in mind that these extensions, these custom script extensions, run under local system. They can't run using a domain account. So I have to pass some variables in here to do some things, right? And those variables are parameters that get passed to the script to do some things. And that's the reason why I needed to enable the SA account, because if I wanted to do some work against SQL Server using local system, I needed the SA account to be enabled. Okay. So let's go look at first the post-deployment script, because that's the one that gets run. This other one just gets uploaded, so that means it's probably referenced by this script. Okay, and again, those are both sitting in our storage container. That's why I had to build URIs up for them so that I could reference those URIs here in the settings for this custom script extension. Okay, let's go look at the post-deployment script, which I believe is this guy, configure VM MSSQL PS1. So let's just look at the main routine here, because this does quite a bit. Okay, main starts at line 257. So the first thing I do is I go and look at all the raw disks. And raw disks would be any newly attached data disk from Azure. So I'm really expecting 2 raw data disks. Okay, I throw some errors if I don't find any raw disks. I I throw out a count of how many raw disks I found to the log, and then I loop through each of those raw disks and I provide some information in the log on what I found. This is useful for debugging. Next thing I do is I go get my Azure data disks. So I do that using the instance metadata service, which we've talked about previously. So this get data disks custom function goes and pulls those data disks from the instance metadata service. And, there's some sequencing issues that can occur. Like, if you run that too early before both disks are attached, you could wind up with some bad information. So I've got polling enabled in this routine to wait a little bit to make sure that all the disks are attached before we return the final set of disks to this script. And so I throw an error if I don't find any Azure Data disks. And then basically, I loop through each of the Azure Data disks and I output information about them to the log, okay, including the name, the size, and the LUN. So the next thing that I'm going to do is loop through each of the local raw disks, which are my Azure Data disks, and I'm going to, kind of like format them and partition them, or partition them and then format them. So we get the LUN for each disk, and then we use that LUN to set up the relationship between the local raw disk from the Windows OS perspective and the Azure data and the associated Azure Data disk. I match them up based upon the LUNs. Okay. So if I don't find a matching LUN, I throw an error. Okay. So the next thing I do is I partition the disk, and I use a GPT partition, which is the more modern. And here's where I basically initialize the disk and create a default partition, which is the entire size of the disk. Next, I'm going to pull the volume label from the name of the Azure Data Disk. So we talked about that earlier in the variables file, where I have a specific format for how I name the Azure Data Disk. And we pull the volume label from there, and we also pull the drive letter from there as the last letter in the name. Okay, so once the volume label and stuff is created, after the disk is initialized, I can create a new partition for the maximum size of the disk, so a single partition. And that GPT partition is created. Now, here's some SQL Server magic. We create a 64K allocation unit size, which is performance recommendations for SQL Server, because SQL Server lays things down or reads things on disk using extents, and extents are 64K in size. So for the best I/O performance against SQL Server, they recommend that you use a 64K allocation unit size. So when we format the disk, we use that special allocation unit size recommended for SQL Server. Right, so at that point, all of our disks should be formatted, like initialized, partitioned, and formatted. And the volume label should be set, and the drive letter should be set for our data in our log disks. So the next thing that this script does is some fancy SQL Server configuration. So first thing we do is go interrogate the registry to find the default instance of SQL Server. And once we find that default instance, we configure the data disks. Okay, so we get all the volumes that are attached and we loop through each of them, and then we handle each volume as we find it. So when I find a volume, I output information about the volume to the log, and if it's any of these volume types, system reserved, Windows, or recovery, we skip those, right? If it's CD-ROM or removable, we skip those. If it's a FAT32 partition, we skip that. If it's a if the volume label is temporary storage, that's going to be our temp disk. And we're going to do something very special with our temp drive. So the first thing we're going to do there is create a folder on that called SQL temp. And we're going to use that folder to store SQL Server temp DB. Now, why are we doing that? When you create a virtual machine based upon the SKU, some SKUs have temporary disks on the host. And from a SQL Server performance perspective, putting tempdb on that temp disk that's local to the host provides a really nice performance advantage, right? So we're assuming that you're using a SKU here that includes a temporary disk, a VM SKU that uses a temporary disk. And we're creating a folder on it because SQL Server can't create tempdb in the root directory. It needs a folder, okay? So we create the folder SQL temp on the temp drive. And then we go and we move tempdb over to that new folder. And then we restart SQL Server. Okay. So that's the first thing we do is move tempdb from the OS disk to the temp drive. And that's a recommended performance best practice for SQL Server. Okay. So that's what we do if it's the temporary storage drive. So I think we're out of it. So next, we're going to look at the file system label, and we're going to determine if a volume is either the SQL Server data or log disk. Okay. And so we do that by looking at the file system label, and if it has SQL data in it, which was my naming convention, we know that's a data disk. Okay, so here we're going to create a folder, and we're going to configure SQL Server to use that as its default data directory. Okay. Similar process for SQL log. Okay, we set up the path and we configure SQL Server to put log files on that drive. So that's when we did our smoke testing and we created tempdb and we were checking whether the data and the log disks wound up in the right place. That happened because of this code, because we had configured the default data and log disk properties here. Okay. And then here's where we actually create those folders if they don't exist. And we obviously need to give SQL Server privileges on those folders, or it would not be able to create data and log files in those directories. And then we restart the SQL Server. And the last thing we do in our code here is this is another best practice, performance best practice for SQL Server, is to move the system databases off of the OS disk and put them onto the newly configured data and log disks. So I wrote a routine for that called move SQL database. Here we move the master database. Here we move MSDB. Here we move the model database. So all of our system databases are then moved to the new data and log disk and off the OS disk when those routines finished. Okay. And then the last thing, this is another performance recommendation, is to move the error log, the SQL Server error log, off of the OS disk. So I just put it on the log disk. So that's where the error log gets written to. The SQL Server error log. Okay. And as usual, we need to grant SQL Server privileges for that, or it wouldn't be able to write to the error log. Okay, so here's where we update the error log. So if we go, okay. So the next thing that I do, and this is kind of counterintuitive, is I set the SQL Server for manual startup. Now, why would I do that? If you stop and deallocate an Azure VM, it gets moved off the host, and the host, when you restart it, it's going to be on a new host. That means the temp drive is going to be empty, and the folders that SQL Server is looking for tempdb are not going to exist, and that would cause SQL Server to fail to start correctly because it would be looking for a folder on the temp drive that doesn't exist. So how do we solve for that? What we do is we create a scheduled task that is on the server, which is set up to run whenever the server is rebooted. Okay, and that task is basically going to be associated with this script. And all this script does is recreate that folder on the temp drive. And if that folder doesn't exist, it creates it, and it starts the SQL Server and SQL Agent service up. Okay, so this is a special thing that you have to do on Azure if you move your tempdb to the Azure temp drive on your VM. Okay, if you put your tempdb on a data disk, you wouldn't have to worry about this. But in the case of the temp drive, since that would get wiped out if you move to a different host, you need to recreate that temp drive. Yeah. So I think that is most of the code. So here you can see we're registering that scheduled task, and we're preparing that temp drive. And that's it. So that is the code that is run by our extension. So let's see if we covered everything in the docs. So we talk about the VM, the NIC, the data disks, the special labels, the attachments, the scripts that get deployed, and we talk about the patch orchestration mode. We use a provisioner to register with Azure Automation desired state configuration. We configure the Windows firewalls to allow port 1433. And then we configure the VM using the best practices for SQL Server on Azure VM. And we, prepare all the disks. We move the databases around. And we set up the startup script to work when the VM is restarted to recreate that temp drive if it wakes up on a different host. So that's the code in the VM MS SQL configuration. We'll see you on the next video.